ahead and continue on with our construction. You went ahead and had to construct a large isosceles triangle on a sheet of paper. You were to label it ARK, with K being the vertex angle. Okay, let's look at step 2. It says construct angle bisector KD with point D on AR. So basically, we need to bisect this angle. So remember how we bisect it. You're going to start with your compass, and you're going to start by making an arc here. Remember, you're going to open up your compass to some arbitrary length. And then what you're going to do is, with your compass at the same setting, or you can make it a little bit bigger, you're going to put the tip of your compass here and make an arc here. All right, and then you're going to do the same thing over here. When you get done, you need to go ahead and draw K through that point, and then you will have a D at some point here. Okay? Now, after you've done that, let's look at what it says. Do triangle ADK and triangle RDK look congruent? Do they look congruent? Yeah. If they are congruent, KD, we call KD a line of symmetry. Okay, line of symmetry basically means it cuts something into 2 equal parts. Let's look at step 3. With your compass, compare AD and RD. What do you notice? They're the same, so basically, is D the midpoint? Yeah. And so what type of special segment is KD?
A median.
Median, it cuts it into median. Good. Okay. Now compare angle ADK and RDK. Do they have equal measures? And what do you notice about their measures? They're the same, and they are 90 degrees. Okay. So compare your conjecture. So we ended up comparing those as a group because we did this investigation in class. And so basically we know that triangle ADK and RDK are the same. And so we're going to utilize that piece of information to go ahead and come up with a vertex angle bisector conjecture. Okay, in an isosceles triangle, the bisector of the vertex angle is also the median and the altitude. Okay? So in an isosceles triangle, the bisector of the vertex angle is also the altitude and the median to the base. Now we have the equilateral equiangular triangle conjecture. Every equilateral triangle is equiangular, and conversely, every equiangular triangle is what? Equilateral. Good. Okay. So basically what that means, if you know a triangle has all the same angles, it's got to have all the same sides. If you know a triangle has all the same sides, it's got to have all the same angles. And then last but not least, the definition of a biconditional. A statement and its converse are both true. Okay, and that's something I want you to file away to a later date. Now on this next slide, we're not going to go there yet. We're just going to look at some examples of the types of problems you're going to have on your homework.
thought that we said that two triangles could have the same angles, but they could have different sides.
What?
Didn't we say that like the AA conjecture was wrong? So that if they
They're
have the same
congruent.
angles-
Okay? This isn't saying that they're congruent. This is saying that if a triangle has all the same sides, it's got to have all the same angles.
Oh, as itself. Not as
Yes,
a-
right, yes.
Oh,
Okay.
okay.
Now, what you're referring to is when we dealt with two triangles. When we looked at two triangles, if they had the same angles, they didn't necessarily have to have the same sides. And that would make sense because if we had, example, I could have two equilateral triangles, right? They're each going to have 60 degrees, 60 degrees, 60 degrees. And I could have 3 as my side here. But then I could also have an equilateral triangle here, 60, 60, and 60, and all of the sides here be 7. Okay, those triangles aren't congruent, but they are both equilateral and equiangular. All right, so the types of problems you're going to have are what we see up here. This one says triangle DEF is isosceles with DF congruent to EF. Okay, so I know that DF is the same as EF. They tell me that the measure of angle D is 67 degrees. So if I know that measure of angle D is 67 degrees, do I know anything else? Measure of angle E is 67 degrees. Because that's an isosceles triangle, angles are opposite the sides, they are the same. DE, they tell me, is 15 centimeters. So what else do I know? FE is 15 centimeters.
Isn't E up
Oh, D, you know what, I wrote that wrong, sorry. Let's go back here. I wrote EF, sorry. DE here is 15 centimeters. Okay, so they want to know what's the measure of angle DFP. Ideas?
Well, 67 plus 67, and subtract that from 180. And then that would, and then divide that in half.
Okay, I could do that. So you could do 67 and 67, which is what? 134. So if I take 180 minus 134, what do you get? 46. Divide that by 2. 23. So that means this is 23 degrees. Yep. So what does that tell me that this angle is right here? 90. Did I really even need to do that? No, because that's one of those conjectures that we just got done looking at. Okay, so the measure of angle DFP is 23 degrees. Now we need to figure out what segment DP is. Yeah, 15 divided by 2 because that's my whole segment. I'm cutting it into 2 parts. I know P is the midpoint. We just looked at that. Okay, so 15 divided by 2 is 7.5 centimeters. All right, let's look at the next one. The measure of DFE is 54 degrees. So that means this big thing is 54. Okay, so I've got 54 degrees right here. DP is 7 centimeters. And I need to find measure of angle DFP and DE. Now, if you notice, the original directions are that triangle DEF is isosceles with DF congruent to FE or EF. So if those are isosceles, I know that these two are the same. I also know that if this is 90, this also has to be 90. Okay, and so I also know that if this is 7, what does PE have to be? 7. So what's the length of that entire segment? 14, and it'll be 14 centimeters. And so last but not least, I have to figure out what DFP is. So I need to figure out what this angle is right here.
27.
It's going to be half of 54. Nice job. 27 degrees. Okay? So all you're doing is utilizing that exact same information that we learned with the investigation. Now, Now, if you get going, you should be able to get done with your assignment before the end of the period. It's short. Numbers 1 through 5 on pages 245 and 246.